Good day, folk. Yes, you back. Another vote of confidence. So it means you like what we do. So go ahead and like. Remember to subscribe because if you do that, every time we drop something, you'll be the first to know. Now let's go ahead and look at our configurations for the operational amplifiers. We have looked at a few. Now we look at, what do we call it? The voltage follower. The voltage follower or unit follower. All right, voltage or unit follower. All right, there is in terms of how it works, it's more or less like the emitter follower. Yes, because our gain is almost one. Well, our gain is one in this case. By design, our gain is one. For the emitter follower, well, the gain is almost one because we lose some voltage through the base emitter junction. But in this case here, we have a gain designed to be one. Now, how does this work? We have to understand. Before I explain the voltage follower, let me just draw it here. Hopefully, nice amplification symbol there. Now this is our typical. Remember, even though we don't show it, there is always the minus VCC because otherwise we won't be able to have negative power, negative outputs, and there's the plus VCC. Even though we do not always show it, remember it's there, right? It might not always be indicated, but it's there. Otherwise, your output will be zero all the time, all right? If we do not supply it, we explained this before, if you do not supply it with power, then its output will be zero, all right? So remember this. I'd like it to be a nice, triangular shape like that. Now the voltage follower, all you do is you have your V in coming through the non-inverting input, and the inverting side is going to be feedback. All right, so what do you notice now? This is not open loop, this is closed loop. Why? We've got feedback. Remember the difference between open loop and closed loop? We've got feedback. So we're taking our output and it is fed back to the input. So this is a closed loop. This is the first case of a closed loop that we're looking at. Now let's understand how the op amp works. The op amp has this tendency, because it is such, because it, remember, it tends to amplify. Its basic function is to amplify the difference. All right, it is designed from a differential amplifier. All right, it is designed from a differential amplifier. I'm sure we've looked at differential amplifiers compared to that section, and the differential amplifier amplifies. It's called differential because it amplifies, or the difference amplifier, it amplifies the difference. What difference? The difference between the two. All right, between these two inputs here. All right, it is a differential amplifier. So because it all it needs is the difference. It, remember, it is a high resistance or impedance gadget. Therefore, it wants to only sample the bigger input and respond to it. All right, so what it does is it therefore does two things. Let's suppose I ground the one leg. Okay, if I were to ground this one leg, it can tell a difference by just sampling. What it will do is it will drive this other leg also. It will drive this other leg also to what? To ground. So this will look like a zero. This will look like it's connected to a ground as well. What is it doing here? Because this is zero, it syncs the other input to zero as well. All right. So it will either sync. If this is a forced input because it's connected to ground, you can't do anything about it. So what it will then do is it will sync that that other input as well to liken the two, and then it can only work on the difference. All right, it is interested in the difference. Why is it? How does it do this? Because it is a very high. Remember, by design, it's actually supposed to be infinite. By design, it's supposed to be infinite, but because of drift and other issues, and it tends to have what? High, because we are using practical components. They don't give us perfection. So instead of infinite, we get very high. In fact, I must emphasize very high. So it's a, remember, we looked at an average of plus minus 1 mega ohm. All right, again, you should be careful. Obviously, what does it mean now? If I'm to have an input here, it means this guy will take nothing here. What has happened here? It has sunk that input to that level. All right. So, and then what you will do? It means now the rest of the input is forced out through the feedback loop. All right. Through the feedback loop. All right. What we call this? It is driven to ground simply because it is sunk to ground simply because the other input is at ground. So what is this called? This is going to look like ground. Look like is basically the definition of what? Of virtual. So we call that virtual grounding. It looks virtually grounded. So we call that virtual ground. If the one input is ground, that one will be sunk to virtual ground. It will look like it's ground. All right. So this is the one thing that it will do. We have to understand how the op-amp works. So all it does is, it doesn't matter what that input is there. As long as the one is forced to ground, it will force the other one to the same thing because it rejects inputs. That is because it's what it is. It is a very high impedance. I prefer to call it a gadget rather than component. But anyway, if you like component better, for whatever reasons, fine. Because I don't believe in a component made up of components. All right. So all right. Anyway, now what then happens is that if you look at the alternative, let's say now I were to force a voltage. Let's say I were to force a voltage to. All right. Let me rather go back to this one. Here. Let's say, however, I had. We're going to look at these configurations one by one. Let's say I had a voltage there. All right. Let's say I had a voltage. I forced a voltage, some voltage here. All right. And I ground the other one. All right. Let's suppose I forced in a voltage there and I ground the other one. What it will then do is it wants to reject the input. So what does it do? It will liken this negative input now, the inverting input, it will liken it to that positive. So if the voltage here is V in, this will virtually be V in now. This will be driven to V in here. So which is what we call sourcing. It will source. So this will either sink or source. So it will sink. When this is grounded, it will sink the other input to ground. But when this is sourced, because there's a source here, when this is a source, it will source instead of sink. It will provide the same voltage there. Right? Whatever V in is here, you will see it also there. Why? It really wants the two inputs to be together because its input is the difference. So it is rejecting that difference. So to achieve that, it has to drive those two to be equal so that the difference is rejected. That's how the gadget works. So it will either sink or source. With that understanding in mind, hopefully that wasn't difficult. With that understanding in mind, let's go on and explain the rest of our gadgets. All right, we'll come and say one by one. Let's understand how this guy will work here. Let me just take it up. Make a copy of this and bring it somewhere there. All right. Let's say from what we just explained now, there is a voltage here. This was my last explanation. There's a voltage here. So what will it do? It wants to liken the two because it is a high impedance gadget. So it will want to liken the two. So that inverting input will also be driven to V in. Okay. Now, what does it do? Therefore, this way it keeps itself balanced. It is sourcing the other one to V in, so it keeps itself balanced so that there is little going into it. It rejects the rest. So what does it mean here? Once this is driven to V in, once our inverting input is driven to V in as well through the sourcing, once it's sourced to V in, which is how we've explained this guy works, it means although V out is also equal to V in. Because why? Because V out and V in are connected together via that loop there. All right, via the closed loop there. So now our output is equal to our input. Now let's analyze something else. Now if V in gain is defined as output over input. Okay, now remember that it drives it to the very same voltage, so it is not going to be what the input and output are going to be in phase in this case. Why? Because our V out and V in, it is not inverted now because it is driven to the very same voltage. It is driven to the very same voltage. If this was negative, that would be a negative. That negative is sent out. If this was positive voltage, that will be driven to it will be sourced to the same voltage. So that positive voltage will be sourced out. So what does it mean here? Our input and our output are in phase. All right. Our input and our output are what? Are in phase. So what does this mean? It means, but, or let's say, which is equal to V in over V in. Why? Because V out is equal to V in. And therefore our gain is 1. All right. Give or take is, remember, the basic unit of this guy is the differential amplifier. All right. So the two transistors might not exactly have what identical characteristics. Therefore, they may be drift there and there. You know. So yes, we may have our let's rather say approximately in practice. In theory, it is equal to 1, but in practice, it is very close to 1. It is very, very, very close to 1. All right. So, but because of the drift and whatever, the different performances in the what in the transistor characteristics of the differential amplifier, we might have some small slight differences, very, very slight. All right. So this is our first. Okay, first we dealt with what? We dealt with the open loop situation. Now this is our first closed loop situation where our V out is equal to V in. Remember, it is similar in operation to the what? If I ask you in an exam, draw me what call this an operational amplifier configuration that operates similarly to what? To an emitter follower, you would know I need the one with what? With unit gain, because remember for the emitter follower, the gain is almost unit as well. All right, so you would know we need the voltage or unit follower. Thank you so much. I hope that was crisp and nice and easy to understand. And let's meet again when we look at further configurations. I know they're going to be very interesting because the op amp is a very interesting guy. Have fun. Ciao. I had one too. Remember to subscribe if you like this, so you get updates when we have new work for you. Enjoy. We had fun.